part 2 of Unit 6, Lesson 4, Applying Properties of Definite Integrals. We are going to follow up our first part of this lesson where we define the properties of proper integrals with some more examples. So example 3 is given in this form. So if the integral from 1 to 5 of 3 times f of x plus 4 dx equals 34, find the integral from 1 to 5 of f of x dx. So what we want to do is we want to take the integral that is given and we're going to break it down using the properties so we can solve it for just the part that we want. So we can use pretty much four properties here. Okay, so what we're going to do is we're going to rewrite this into two integrals because we have that addition. So this will be 3f of x dx plus the integral from 1 to 5 of 4 dx. And then the next thing we can do is we can factor out our constant of 3. So that will be 3 times the integral of 1 to 5 of f of x dx. So now we have this isolated here. This is the part we're going to solve for, plus the integral from 1 to 5 of 4 dx. And so now what we have is we have 3 times the integral that we're looking for, 1 to 5 of f of x dx. And now we can use our property of integrals and solve and take the integral of the constant 4. So that's going to be 4 times 5 minus 1. And we want to remember that we were originally given that this integral equals 34. So now what we're going to have is 3 times our integral from 1 to 5 of f of x dx plus 16 is going to equal 34. So solving this for f of x, I subtract the 16. I'm going to have 3 times the integral from 1 to 5 of f of x dx will equal 18. And then I have to divide both sides by 3. So I get that the answer is 6. Okay, so now let's talk a little bit about even and odd functions, because knowing that can help us sometimes determine an area under a curve. So suppose we're given the condition where we're integrating f of x from 0 to 3 and we get a value of 8. So what happens if we know that f is even and now we're going from negative 3 to 3? So let me just sketch a graph of an even function. Even though we don't know what this f of x looks like, let me draw a parabola here. And then what I can see is if I make this negative 3 and here's my positive 3, and if I know this area here is 8 units, this is 8 units, then since it's even, it has to cover the same amount of area over here. So this side is also 8 units. So what I'm going to see is if I take the integral now from negative 3 to 3, I'm just doubling the integral from 0 to 3. So I'm going to get 16. So that's how an even function works. Now, again, we're going to assume that our function value, our integration from 0 to 3 is going to equal to 8. So now what happens if, again, we go from negative 3 to 3, but we have an odd function? So let me just draw a very simple odd function here. Let's just do the line through the origin. That is definitely an odd function. And so if we were originally told that the area, this is 3, if that area was 8 units, and now we're going to include the area from negative 3, what you'll notice is these are opposite areas. So we are going to end up with an area of 0 because this area is 8. The area below the x-axis is 8. And remember, to get the net area, we subtract areas below the x-axis. So our integral is going to give us a value of 0. So that's a nice little property to think of when you're doing integrals and you're looking for area under the curve. Okay, so for the last example, we are to sketch these and then to find the area, to sketch it and then to evaluate it by using a geometric formula. Okay, so if we sketch the first one, we have a line, and we're just in the first quadrant. So here's my X, here's my Y. So 1, 2, 3, 4, 5, 6, 7, and then we're only going up to 4. So if I sketch this line, what I have is I have this line. So here is the part of the line that I want. So if I look at this shape that I have our old friend, the trapezoid. So I have my two bases have heights of 4 and 7. And then I have a base of 3. So my area formula ends up being 1/2 the sum of my bases times the width of my trapezoid. So this is going to give me 33/2, which is also 16.5. Okay, so next I am going to have a semicircle. That has a radius of 2. So, see if I can make this look circular. Okay, like that. So now what I can do is just find the area of half a circle with a radius of 2. So I'm going to take 1/2 pi r squared. So that is going to be 1/2 pi times 2 squared. So that'll be 1/2 of 4 pi, so I get 2 pi. Okay, next one. Now I have an absolute value function that has been shifted up 3 units. So let me draw this down here because I'm going to need some room because it's higher up on the x-axis. And I'm going from -2 to 4. So this is now shifted up 3. Okay, so at -2, I'm going to be at 5, and this is going to come down to here. And then at 4, I'm at 7, so 3, 4, 5, 6, 7. So it's going to be a little further up like that. So what I can do then is I can create these two trapezoids here and find the area of both of them. So this is going to be 1/2 my two bases. So here I have a base of 3, and on the other side I have a base of 5, and the width is 2. And I'm going to add to that the other trapezoid where I have a base of 3 and another base of 7, and this time my width is 4. So when I do this, the first trapezoid has an area of 8, and the second trapezoid has an area of 20. So I get a total area of 28. Okay, so the cube root one, now notice my limits. This one might seem a little tricky, but you want to remember we have an odd function here. So I don't really have anything to do. I already know that area is going to be 0. But let me sketch it so you can see it. The cube root function, we're going from -4 to 4, is going to look like this. At 4 we're not at. So if you look at these two areas, what you're going to see is they should be exactly opposite of each other, and so they're going to cancel each other out and give you an area of 0. So you don't have a lot of tricky like geometry to do there for that one. Okay, so next one, we have another line going from 1 to 4. So we're going to draw this graph. And so we have to go to 14. So I'm going to count by 2's here. Okay, so at 1, we are at 5. And at 4, we are at 14. So here's my line. And so I have this trapezoid here, that here has a height of 5, here is a height of 14, and it is 4 units wide, so this is going to equal 1/2. 4 plus, whoops, not 4, 5 plus 14 times 3. So that's going to be 3/2 times 19. So that's going to be 57 over 2, which is also the same as 28.5. You could leave either answer is fine. Okay, so the next one, what I'm going to do is I'm going to divide it up into pieces. And what I'm going to see is, I'm going to graph each one separately then. So I'm going to have the integral from 0 to 2 of 1 dx plus the integral from 0 to 2 of the square root of 4 minus x squared dx plus the integral from 2 to 5 of 3 minus x dx. Okay, so the first graph is going to be a horizontal line because it's a constant. And it's going to be this rectangle here. So it is going to have an area of 2 because it's 2 wide and 1 high. The second one, we don't have to redraw because we did it already. We now only are going from 0 to 2, so we're going to have a quarter of my circle. So I'm going to divide my 2 pi by 2, so I'm going to get pi. I'm not going to redraw that one. Okay, so now we're going to have to do this part, and I'm actually going to split that up. I'm going to make this into the integral from 2 to 5 of 3 minus the integral from 2 to 5 of x. Okay, so that way it's going to be a little easier to do because that's going to be another, let me do that one down here. That's another rectangle. So I'm going from 2 to 5, and now it's going to have a height of 3, so I'm going to have this rectangle here that is 3 by 3, so that's 9, so I'm going to have a 9 here. And then I'm going to subtract from that this shape, which is going to just be x here. But I'm only going from 2 to 5, and since this is the identity function, this will have a height of 2, 5, and it's going to have a width of 3. So the area of this is going to be 1/2 7 times 3. So I'm going to get 21 over 2, so plus 21 over 2. So putting this together then, let me use a different color. I'm going to have 11 plus 21 over 2 plus pi. So that's going to give me, oh wait, did I make a mistake here? Oh, I have to subtract off this area. I'm sorry. I knew I was missing something. Okay, so this 21 over 2 is going to be subtraction. So this is a minus here. So let me just use this. Sorry. So this is a minus. All right, so I'm going to have, so that part's going to give me 1/2 plus pi, and that's going to be my answer. Okay. And that's going to be the end of this section, and we will do some questions in class tomorrow and go from there.